At this point in the course, we've seen that we can do console output like this and console input using cout and cin. Now there's another way of doing output to the console, and that is using the printf function. We've also seen that we can do stream manipulation, where we can set the precision and stuff like that, and we can do similar stuff with the printf function. For this example, I'm including cstdio for the C language standard input and output. Alright, and here I have a C string which we will use a bit later here, but in this next line I'm doing printf and I'm going to print out hello, so I pass in an argument. I'll just do Control Shift spacebar here, and you can see this takes in as an argument, it takes in a pointer to a character constant. Basically it takes in a C string, and that is called format, and then you can see we have a comma, so we have a second argument. We have comma and then we have dot dot dot. That's because this takes in a C string followed by a list of format specifiers or format codes, and we will talk about that here in just a second. But this basic function call, what we are passing in is the C string with a new line, so hello with a new line, and that should print out as we would expect. Pull and run, you can see it prints out hello to the console, and that is what we get. As I mentioned, this printf function accepts two arguments. If the format argument includes something called format specifiers, which are sequences beginning with the percentage symbol, then those are formatted, inserted, and the resulting string gets printed out. So what do I mean by that? Well, let's go and insert one of those. We will start with characters and strings. For example, let's say we have this, I want to remove that. We can start with the percentage sign followed by a C for character. So that is our first argument now, that C string. What do we have? We have a hello followed by a format specifier, which is this percentage symbol followed by C. That is for character, and notice that we can insert that even though we have to the right of that we have that new line character, right? Then for the second argument, we actually go in and specify that character. I will specify the exclamation, and that is now going to be inserted where the format specifier is. That is going to format that C string, which then gets printed out. So let me build a run, we can see what we get. Notice that we get the exclamation now. And so what I can do is I can change that to something else. I can change that to something else now, such as the question mark, for example. Observe that now we get a question mark instead of an exclamation. Of course, the reason why I have a new line down here is otherwise if I build a run, notice that we have the press any key to continue right at the end of that. I don't want that. That's the only reason why I have the new line character in there. But notice that this is the specifier or the format code. The format specifier, it begins with the percentage followed by a specific specifier or code, in this case C for character. You also have S for sequence of characters, not to be confused with the C++ standard string. Okay, I'll just go and remove hello there at the start. To get started, I'll just go and use a literal. For the first argument, we have a C string, and that has a format specifier, %s for a string of characters, followed by a new line. Then for the second argument, we also have a C string, literal, and I will build around that. And we get hello printed out. Now, of course, we have a C string up here as well, so I can just go and use that in here instead of a literal. And I can build a run and we get hello human printed out. A couple more notes on this. S again is for sequence of characters, so it is not for standard string. So that is not to be confused with the standard string. For example, if I do actually, I will call that std string for standard string. Copy that, and if I paste that in here now, what do you think is going to happen? Well, let me build a run and we can see that we will get a bunch of weird characters. This is not going to give us the result that we would expect. That is because this std string here is a standard C++ string. Based on what we've discussed so far on strings and standard strings, go ahead and pause the video for a second and fix this issue. That is, we want to fetch the C string that the standard string is managing, and we want to print that out. Alright, I'll just go ahead and continue here. We want to use the member function on this. That is .c_str to fetch the C string. build and run, and notice that this works fine now. And one more thing before we move on to the next couple of examples, I'll just copy this and paste that, and then I'll go and modify this second one here. What do you think is going to happen if you have two of these percentage characters next to each other, like so? Well, let's go ahead and build a run and see what we get. Notice that that actually prints out the percentage character. So I just wanted to mention that. Before moving on, I would like to note the format or the prototype of the format specifier. As I mentioned, it starts with a % character, and that can follow by an optional flag, which is basically going to modify the output. It can be an alternate representation. It can allow us to show the positive sign. Then it can also specify the width. As with the field width that we covered before, those are the minimum number of characters to be printed. That is followed by the dot operator and the precision for floating point, and then followed by the length. Now the length is basically, let's say you have a long int or a long int, then you can provide L for long int or LL for long int, and that is followed by the specifier, so S for string of characters, C for character as I mentioned, D or I for decimal integers, and so on. I will reference some documentation at the end of the lecture. A couple of notes before we move on to additional examples. We can see that we have to include the cstdio, but actually if we go ahead and we include iostream, then we don't have to go ahead and include this. That is because printf will come in through iostream. If I go ahead and build a run, you will see this prints out hello human, and that works fine. Also, if we have, this is also true for other files such as string, for example. If I build a run, we can see that this should work fine here. I'm showing you this out of interest, but for the most part, if you want to use printf, then go ahead and include iostream or go ahead and include cstdio. I would also like to note that this printf function is going to return the number of characters written if successful. If this function returns a negative value, then an error has occurred somewhere. For example, this is going to evaluate and print that C string out, and it's going to return the number of characters written to this chars written integer, and then we are going to print that chars written out. So let's go ahead and see what we get. We get hello human and 13 characters. Hello human is a C string containing 13 characters, including the null terminating character. In this example, we will look at integral values. So we have decimal integers, we have the I specifier, and also the D specifier, so you can use either one of those. And then for unsigned, you can use the U, again for the unsigned decimal integer. Then we can also do hexadecimal and octal display, so I'll just go and separate those out for readability, and I will build and run. And you can see we get the decimal is 255. And then for hexadecimal, we get F and F printed out. Octal is 377. We have seen examples of hexadecimal and octal before. Go ahead and comment those two out. Also note that you can change the capitalization. So for hexadecimal, you can change the lowercase to uppercase. And that is going to display this value here in hexadecimal, but in uppercase. For example, if I build and run, notice that the hexadecimal is now uppercase FF as opposed to what it was previously, which was lowercase. The format specifier, also referred to as the conversion specification, can also contain sub-specifiers or flags. For example, we can use the pound or hashtag character, and that will essentially give us an alternate form of the conversion. In this example, we have hexadecimal and octal, and as I talked about previously, those are easier to read as hexadecimal and octal values if they have the appropriate prefix, 0x with hexadecimal and a 0 with an octal value. And we can get that alternate form of this output or conversion in the format specifier by using that pound. So let's begin with the percentage symbol, pound, and lowercase x for this example. And for the octal, we have the percentage, the pound character followed by O. Now if you build a run, notice that we get the prefix. For hexadecimal we get 0x, and for octal we get 0377, right? Notice that for hexadecimal this is lowercase, but we can change that to uppercase. as I mentioned before with the uppercase X, and if I build a run now, notice that the X and the FF is uppercase, and we still get that prefix, so we get prefix 0x uppercase, X double F uppercase as well. This is basically a sub-specifier or a flag that is contained within the format specifier or conversion specification. In this next example of this integer, then I do printf decimal percentage I followed by a new line. In the next statement here, I do a space before I for integer, or you can use D. And then in the next printf invocation, I do plus. And the plus is a flag which is going to allow us to print out the positive sign. So this is currently positive 255. Here where we have a space, that is going to add a space, okay? Unless that is negative, we'll look at that here shortly. Then in the next couple of printf statements, I'm going to modify the field width. Following the percentage, I specify 10 for the field width. In the next printf invocation, you can say I also provide the plus, that flag, before I specify the field width. But that is going to be right justified in these two printouts. In the final printout, that is going to be left justified because I use the minus sign. So don't get the minus and the plus confused. The plus is going to allow the printout of the plus sign with positive values. The minus sign is going to left justify. Build around that. And you can see that decimal prints out. As I mentioned, it's going to print out here with a space in the second printout. And the plus sign is going to print out in that one right here. Because I've specified that I want the plus sign to print out because I have the plus symbol here, the plus flag. Okay, then I mentioned that as with the manipulators, we can modify the field width. And you can see in the second one, I also display the plus. In the final printout, we have left justified that field. So let me go and modify that to a negative value. Build a run. And now you can see the space here does not really take effect because it has the negative sign in there. And the same in the third printout, it's simply going to show us negative now instead of plus because that's a negative value, not a positive value. And then in the field width, again, we will get a bunch of negative values. The final one is left justified. I would also like to note that if you have a long int, then you can specify that particular length. For example, we can specify that right before we have the actual specifier, so I, for example, just like that, okay? And if I build a run now, that still works fine. And if you have a long, then that will be LL and so on. Again, I will link you to some documentation at the end of the lecture. One more example before we wrap up this lecture. I want to demonstrate to these two printf function invocations that we can prepend with blanks, or we can specify that we want to prepend with zeros. So with this first one here, in other words white space or spaces, we have a field width of 10 for both of these. In the first one, I also have the plus for positive values that will show the positive sign, that is the plus flag. In the second printf function invocation, you can see that I have a 0 flag, and that will prepend with zeros. And in the final one here, I'm just going to left justify by using the minus flag, also with a field width of 10. Notice that if I build a run, we prepend with blanks, and then we can prepend with zeros, and then I'm going to left justify in that final one. Okay, so next we have the floating point. I'm also demonstrating the field width with that. For example, we have the double pi down here, and this is how I go and print those out. So in the first one, we use F for floating point basically. That's an easy one to remember as well. In the next one, I actually go and specify a field width. So in the first one, we don't have a field width, of course. In the second one, I have a field width. That's going to be right justified. That is also why we have that bit of a space here, which we don't have in the first one. And that's because we have a field width. And if we have a field width specified, again, that is going to right justify by default within that field. We can change the precision by doing this right here. We use the dot operator. That is following the width specification, we do dot, and then we specify the precision. Again, the final element within the format specifier is going to be the actual specifier, in this case F. And again, if I build a run, this is the output that we get. The previous floating point output is going to end in a 9-3, so 5-9-3, whereas the final one is going to end with 5-9-2-6-5. And that's because you have more precision in that output. Again, C++.com is a great reference for this because it's not overly complicated. It's easy to follow. It really shows you only what you really are concerned with, and that you can find what you need easily and quickly and easily in here. Okay, so at the C++.com website /reference/cstdio/printf, you will find this documentation here. Notice again the format specifier follows this prototype that I summarized for you previously. The specifier, the flags. Here, down here, you have the flags. You have a table of the specifiers as well. Then followed by the precision, followed by the length, and then finally the specifier. Here, for example, in the flag section, it shows you the hashtag or the pound, which is used with OX or uppercase X to prepend, so that for the hexadecimal, for example, we get 0x to make that value easy to recognize and to differentiate that value. Alright, then you also have down here, you have the length. I showed you L, for example, for long, LL for long int, and so forth, and a couple of examples. Alright, so this is a really simple and concise reference for you with all of the tables and stuff that you need. You can also go ahead and search on the cppreference.com, but again, I prefer this documentation here.